In this session, we are going to know about the retail domain. In the retail domain, you have a applications are there. The inventory management system, smart payments, smart vending machines. And then coming to the retail inventory management system. What is the inventory management system? Here, IoT system enable the remote monitoring for inventory using data collected by the RFID reader. Here, in this case, inventory management system. Here, the inventory management system for the retail has become an important in a recent year with the growing competition. While overstock of products can result in a additional storage expenses and risk. Here, under the stock can leads to loss of revenue. The IoT systems, here you are using the IoT systems using RFID. That means for each and every IoT system, you will give a some RFID. If you see here, you have a different items are there. First one item, two, three, four. In the diagram here, you will identify the different items. For each and every item, you are giving a tag ID, the reader's location, and then time of a reading. Here, that means what is the necessity of taking this one but that means RFID tag can help in inventory management system and monitoring right inventory levels here. Here RFID tag attached to product allows them to be tracked in a real time so that the inventory levels can be determined and the product which are low stock can be a replacement. That means in the diagram here, you will identify the if any stock low low stock. That means if you have the very less stock, that particular less stock here replaced with the another one. That is a main intention of this inventory management system. Here for this one, you developed so many IoT systems, uh, and not only this information here, the RFID based inventory management system for the time sensitive material also described here. And then the tracking can be done by using RFID readers attached to the retail stores also used here. And then IoT system enabled remote monitoring of inventory using a data collected by the IoT readers also invented by using this IoT system. That is the inventory management system in a retail. The next important one is a smart payment. Here smart payments in the sense everywhere you are identify the phone pay, Google Pay, and then Paytm, like that. These are all smart payments. The smart payment in this case here, you have a different solutions are there for this smart payment. Here solutions such as a contactless payment, the contactless payment powered by the technologies here. What are the technology you are using? Near field communication and then Bluetooth technology here. Here coming to the this important thing here is the smart payment solution such as a contactless payment powered by the technologies such as a near field communication and Bluetooth. The near field communication is a set of standards for smartphones, other devices to communicate with each other by bringing them into some proximity. That means the customer can store the credit card information in their NFC enabled smartphone and make a payment by bringing a smartphone near the point of sale terminal. That is a if you see diagram, you will identify the smartphones here. You have a different smartphone. That means you from from the mobile phone you will do some smart payment. From car also you will do the smart payment. Like that you will have the different smart payment technologies are there. Next one, smart vending machines. Here what is exactly smart vending machines here? The coming to this one, the smart vending machine here. This is a smart vending machine. If you see the diagram here, you will identify the vending machine components, and then the smart vending machine connected to the internet. Here It's always connected to the internet here, and then it allows the remote monitoring inventory levels. Here, the smart vending machine here, vending machine monitor its operation, send a data to the cloud, which can be used to predict the maintenance. That is a main intention for the smart mission. Uh, Smart mission. Sorry, ఇక్కడ నుండి కూడా వినపడుతుందా సార్? And then not only here, based on this smart vendor mission, you develop a different application here. The user can save their preferences, the favorite products, and send a smart vending machine, monitor its operation and send a data to the cloud, which can be used for predicting the maintenance. The smart vendor machine communicate with other vendor machines. Here, other vendor machine in their in city and share their inventory level so that the customer can route it to the nearest machine in this product. That is a important thing in a smart vendor mission. And then coming to the next important one, logistic. The application for the logistic is a route generation and scheduling, fleet tracking, shipment monitoring, and then remote vehicle diagnostics. These are all different applications for the logistic. Logistic in the sense, for example, transportation. In the transportation, some application is there, remote vendor mission. Here, if you see here, this vehicle having a remote vendor diagnosis, and then fleet tracking is there, and then shipment monitoring. This is a some information regarding the all these things. Here coming to the first one, route generation and scheduling. Here, how can you generate in the different routes here? The modern transportation system driven by the data collected from the multiple sources, which is processed to provide a new service to the stakeholders. Here, by collecting large amount of data from various sources, process data into useful information. Data-driven transformation can provide a new services such as what are the services here? Advanced route guidance, dynamic vehicle routing, and then some of the customer demand for pickup and delivery problem. That is a route generation. And then the route generation and scheduling system can generate a end-to-end route. If you see here diagram here, you are performing the end-to-end route. The middle indicates the middle have the middle destination. The middle house indicates the distribution center. The shipyards distribution center is there. From here to distribution center, you are having the different routes. The route generation and scheduling system can generate a end-to-end routes using combination of route pattern and transportation mode. The feasible schedules based on a availability of vehicle, and then IoT based systems backed by the cloud can provide a fast response to route generation queries and can be scaled up to serve a large transportation network. That is a important concept in a route generation system. Other one is a the other important one, fleet tracking. Use GPRS to track the location of the vehicles in a real time. Fleet tracking system. Here, in order to identify the vehicles tracking, that means that is called their vehicle tracking. The vehicle fleet tracking system uses a GPR technology to track the location of vehicle in a real time. Here, that means I want to, for example, I'm having some transportation company. I want to track the location where it is. That means from Vijayawada to Hyderabad. That means one vehicle going you go to Hyderabad. At that time, I want to track the vehicle where it is. Here, for this one, you will use a fleet tracking system. The cloud-based fleet tracking system. Here, the diagram shows that the cloud-based fleet tracking system. The, the cloud-based fleet tracking system can be scaled up on demand to handle a large number of vehicles. Here, not only that information, for this vehicle, you are having the different alert messages. Here, which type of alert message you are sending here? The alert messages may be uh, SMS alert messages, MMS alert messages. Those are all different alert messages. The vehicle location and routes can be aggregated with analyzed for detecting the bottleneck in the supply chain, such as a traffic congestion on one road, assignments and generation of alternative routes, and supply chain organization. Here, another important, some of the person proposed one system based on a fleet tracking system. Here, the fleet tracking system for the commercial vehicles also described by using IoT system. Here, this type of system can analyze the messages sent from a vehicle to identify unexpected incidents between actual and planned data so that the remedial actions can be taken. That is called here fleet tracking system. The second important one, fleet tracking system. This diagram shows the a person showing, that means tracking some vehicles, large vehicles or small vehicles, and then even flight also you will track the by using this system. Next important one, shipment monitoring. Here, what is the shipment monitoring here? You will have the large vehicles are there. Shipment monitoring. What is the shipment monitoring? The shipment monitoring solution for the transportation systems allows monitoring the condition inside the container. Here, if you see here, the container consists of a food item or anything here. It's having the food item. Here I want to identify the wastage of food. The wastage, that means the food item, some food we can waste some food. That means that kind of information you will identify by using this system. Here in this case, the shipment monitoring system identify the condition inside the container. For example, container fresh food produce can be monitored to prevent a spoilage, the spoilage of a food. And the IoT based system monitoring system can use the sensors such as a temperature sensor, pressure sensor, humidity sensor to monitor the conditions inside the container. If you see the diagram here, large number of vehicles are there. Yeah, these vehicles having the food, the spoilage of food. Here you will identify the spoilage of food in a container, and then to monitor the conditions and send the data to the cloud where it can be analyzed to detect the food spoilage. That is a important thing in a ship monitor. Next important one is a remote vehicle diagnostics. Diagnostics in the sense, the main intention of diagnostics here is identifying the faults in this vehicle. Here, what are the vehicles having a different faults? Here, there is a some information having here which type of information here, the fault, that means even though fault existed, the vehicle should run. The here in this case, remote vehicle diagnosis system detect a faults in a vehicle and then give a warning to the vehicle. Here it's give a warning to the vehicle, and then this part is damaged, then you will do some remedies like that. It's give some information, and then here you are using a different IoT systems. The system use onboard IoT devices for collecting the data on a vehicle operation. Here the vehicle operations may be speed of the vehicle, RPM, etc., and status of various vehicle subsystems. That is a remote vending system. Next application, we are coming to the agriculture. In the agriculture, one is a smart irrigation system. Next one is a greenhouse control system. Here, the smart, if you comes to the diagram having the smart irrigation system, here we will identify the wet in a soil, moisture. The moisture levels in a soil, you will use this system. We are coming to this one. The smart irrigation system used to identify determine the moisture amount in a soil. I am telling you some information regarding this one. Here, the smart irrigation system can improve the crop yield while saving the water. The smart irrigation system can use a IoT devices with the soil moisture. That means soil wet. That means soil moisture sensor to determine the amount of wet in a soil and release a flow of water by using irrigation pipes. Here, the smart irrigation system can collect the wet levels and measurement on a server. That means here also you will apply some of the IoT devices. Our main intention here is a continuous flow of water. If is there any damage, that means continuous flow of water. For identifying the continuous flow of water, you will use this system. The next important system here is a greenhouse control system. Here, what is the main intention of greenhouse control system? To identify to improve the productivity. To identify and improve the productivity, you are using the greenhouse control system. What is the greenhouse system here? Greenhouses are structures with glass and plastic roofs that provide a conductive environment for growth of plants. Here you have some condition inside a greenhouse. Here monitor and control to provide a best condition for growth of plants. Here, the temperature, humidity, soil moisture, light and carbon dioxide levels are monitored using sensors. And then you also identify some conditions are controlled automatically using some of the activation devices. IoT system play an important role in a greenhouse control and help in improving the productivity. The data controlled from various sensors is stored on a central server. Here, that means here also uses a different devices for controlling the humidity levels, temperature levels, and then different real time. That means physical parameters. These different physical parameter in a greenhouse. That is called here agriculture. Coming to the industry, the application for the industry domain here is a mission diagnostic and prognosis. Indoor air quality monitoring. Indoor air quality monitoring. Here, if you see the diagram here, the industry consists of a room, for example, mission diagnosis, indoor air quality monitoring. For identifying the indoor air quality, you are using a different systems. Here, the first important thing here is emission diagnosis and prognosis. Diagnosis, false, identification of faults. Here, mission diagnosis refers to predicting the performance of the mission by analyzing the data on a current operation condition. How much deviation exists from a normal operation condition. What is the mission diagnosis? Determining the cause of mission faults. Here, IoT plays an important role in both diagnosis and prognosis, identification of some information. For doing that one, you will have the different sensors. Here, for designing a different IoT systems for identifying the faults in a industry. Faults in a industry, not only faults here, the quality, air quality conditions also identifying by using some systems. That is a simple information. Next one, indoor air quality monitoring. Indoor air quality monitoring system. Here, what is the system here? Monitoring the indoor air quality in factories is an important for the health and safety of the workers here. Harmful gases are there. CO, NO, NO2 can cause a serious health problem in a factories. Here, for monitoring that information, IoT-based monitoring system can help in monitoring indoor quality. Here you have a computer. Here you have a, for example, if you see the diagram here, indoor quality, outdoor pollution is there, CO2, NO2, NO, like the different climatic condition, identifying the climatic condition, indoor as well as the outdoor. That means identifying the pollution. For identifying the pollution, you are using the different IoT system. The final one here is a health and lifestyle. Here, health and lifestyle indicates the fitness monitoring and then vital sign monitoring. Health and that means health and fitness monitoring system. Here comes to the health and fitness monitoring system. Here, wearable IoT devices. Wearable IoT that allows a non-invasive and continuous monitoring of parameter can help the continuous health and fitness. These wearable devices have may be in various forms such as belt, watches. Here, these devices type of wireless sensor network here. Sometimes, if you see this diagram here, sometimes you will use a wireless sensor networks. These sensor networks identifying the what is this work here? This is called here body area networks in which the measurement from a number of wearable devices are continuous sent to master node. Here the master node is a node device, a node or IoT system who sends a data to server or cloud-based backend for analysis and achieving healthcare provides that can analyze the collected data. That is a thing you are using these systems. This system help measuring the health monitoring techniques. Coming to the wearable electronics devices, last and final concept in this case here is a wearable electronic devices. The wearable electronic devices. So many different wearable electronic devices are there. Some of the devices smartwatches, some of the devices glasses, and then wrist hand, and then some of the electronic devices are there. Here, these devices provides a various functions and features to assist us in various daily activities and making us lead a healthy lifestyle. And then some of the smart watches are there. Here, what about these smart watches here? These smart watches that run mobile operations. So that means provide a enhanced functionality beyond the timekeeping. Like that, you are having different things existed here. This is a today's topic. Thank you.